This AI video was made using a technique almost nobody is using yet.
It's not a new model, it's not a better prompt. It's a century-old drawing trick ported to AI video. To explain why it works, let's take a short detour.
We'll speedrun how GPUs work, why AI feels intelligent, and how to keep systems from breaking. Then the technique. Let's go. At a mechanical level, AI is not intelligent. It doesn't think the way humans would. It's actually guessing. It samples from a probability distribution learned during training and selects outputs that best fit the constraints it's been given. AI doesn't have a mental model of the world. It has patterns, a ton of them. So when you ask it something, it's actually matching patterns at scale. The magic behind why this feels impressive isn't intelligence, it's parallelism. But bookmark that thought. We'll dive into that even further. A CPU tries one thing at a time. A GPU tries thousands. They let you aim an enormous amount of computation at one very small problem. So when you see a clean AI output, what you're really seeing is the survivor of massive parallel computation. Millions of guesses.
There can be only one.
One selected. So in a nutshell, what an LLM is actually doing isn't reasoning forward. It's repeatedly asking one narrow question. Given everything so far, what comes next? That question is evaluated millions of times per second inside a structure shaped during training. This is why AI images and video often generate wild hallucinations. The saying, "A picture is worth 1,000 words," rings true, and AI confirms it. Language is forgiving. If something drifts, your brain patches it. With images, there's a ton of things AI has to get right. Perspective has to line up. Lighting has to stay consistent. Objects have to be in the same place. AI doesn't carry a persistent world model. So in AI videos, each frame is a fresh guess, drawn from a probability space, conditioned on the prompt and recent frames. That's why faces drift, hands melt, motion flickers. The magic isn't intelligence, it's parallelism. AI doesn't arrive at an answer by thinking longer. It tries more possibilities at once. More pixels means more chances to be wrong. Parallelism hides that until it can't. So here's something interesting. Video games already solve this problem. Game developers learned over time, don't render the entire world. Only render what's in view. Everything outside the camera is simplified, delayed, or ignored. All the power goes into what you're looking at. That's what gave rise to NVIDIA and GPUs. So fundamentally, AI works the same way. In AI, context is the viewport. Inside it, AI looks sharp. Outside it, there is no world waiting. Only probability. If you find this mental model more useful than a list of prompt hacks, consider subscribing. We're going deeper into the infrastructure of AI. So that's why longer prompts often fail. You're widening the viewport instead of narrowing it. More instructions don't mean more clarity. They mean more ways to be wrong. Variance increases. Outputs destabilize. Prompts set conditions, and the constraints shape behavior. To understand why constraints work, we have to look at how reality behaves under pressure. It's essentially a physics problem. This is where a quantum physics analogy actually helps. Stay with me. We're not going to get into the physics or debate whether we live in a simulation. What actually matters is what physicists observed, literally. So, in the double-slit experiment, scientists shot tiny bits of light at a wall. You'd expect each bit to land in a simple pattern like the double slits, like shooting paintballs at a fence. But that's not what happened. When they didn't watch the experiment closely, the pattern on the wall spread out and looked messy. Lots of possible paths. When they did watch it, the pattern snapped into the shape we'd all expect. Nothing magical changed about the light. What changed was the observation. Observation acted like a rule, a constraint. That's the only takeaway that matters. When you constrain observation, patterns emerge. When you remove constraints, outcomes spread. This also isn't just a physics quirk, it's a design pattern. In software engineering, when we deal with high variance, unpredictable systems, we don't just hope for the best, we box them in. When a service is flaky, you don't trust it more. You wrap it, you isolate it, reduce its surface area, and add observability. Classic strangler pattern. You don't rewrite the system all at once. You box in the unreliable part until its behavior becomes predictable. That's how large systems actually survive at scale. Fundamentally, AI systems are services behind APIs. Treating them like mines is a mistake. Treat it like unreliable infrastructure. Don't argue with the service. Design around it. What's wild is, early animators figured this out almost a century ago. They didn't redraw the forest every frame. They used cell animation. Static background, moving subject, brain fills the gaps. So here's the modern version. Static plate, generate the background separately. Generate the characters and extra layers on a green screen. No background guessing, no interference. Composite the layers, bring them together. By removing the background, you're freeing most of the GPU's attention. The probability wave collapses onto one thing: consistency. Old tricks, new tools. Here's the takeaway to 10x your AI skills. Stop asking AI to understand. Start designing the apparatus it operates inside. Decide where to point the computation. AI is strongest when the viewport is narrow, weakest when it's wide. Prompts aren't the steering wheel. Constraints are. Treat AI like flaky infrastructure, not a mind. Wrap it, box it, observe it. If you're building with AI, I'd love to know how you're designing constraints. Drop a comment below. If this video opened up your viewport, hit that like and consider subscribing. And I'll see you in the next one.